Hi everyone, thanks for coming, thanks for having me. So my talk today is going to be about spooky action at a distance in quantum mechanics. So, just to give you a preview, my thesis is going to be that the apparent action at a distance involved in quantum entanglement is the spookiest phenomenon known to science, known to modern science. Okay, so that's the very important, controversial, philosophical thesis that I'll be developing today. And here's the argument that I'm going to present. Premise one, ancient Judaism would have found penguins to be an unacceptable meal. Premise two, Avatar: The Last Airbender is fun to watch. Conclusion, quantum entanglement is the spookiest. Okay? Okay, so hopefully that's fairly intuitive how we're going to go from P1, P2, P3. I know some of you are thinking, not this again. Every time I go to a talk, somebody's trying to link up ancient Judaic culinary practices and mid-2000s cartoons, but I hope you'll find I have a reasonably fresh take on it. So if that's, unless we've got any questions off the bat, let's begin. This is actually what I'm going to be doing. Okay, so this is the original line, spooky action at a distance. It's in a letter by Einstein to Born. He says, I cannot seriously believe in it, that is a statistical interpretation of quantum mechanics, because the theory cannot be reconciled with the idea that physics should represent a reality in time and space, free from spooky actions at a distance. Free from spooky actions at a distance. So Einstein didn't like a lot of features of quantum mechanics, despite being one of the people that developed it. He didn't like, for example, the indeterminacy that it appeared to entail. So it seems quantum mechanics seems to have these things that where the outcome is just, it could have been this way, it could have been that way, and nothing actually determines which way it went. So he didn't like that. That was his famous God doesn't play dice with the universe thing. But he also didn't like this aspect of it, that some parts of quantum mechanics make it look like things are happening across space with no apparent connection. And he called it spooky. Real spooky phenomenon. So some questions that I'll kind of structure how we go forward. What is quantum entanglement? So I'm going to explain that just right off the bat. We'll talk a little bit about what it is. And then I want to ask, why is quantum mechanics spookier than other kinds of action at a distance? So this is not the first time that action at a distance shows up in physics by far. And even more fundamentally, what makes something spooky? So a bunch of this talk is going to be taken up by the question of spookiness in general. Try to come up with a general formula for what makes something spooky, and then I'll come back and apply it to quantum entanglement. So that's the slightly more serious plan for this talk. It is going to involve Avatar: The Last Airbender. Anyway, okay, so let's start from quantum weirdness. What makes quantum mechanics a particularly weird theory? So suppose you got the following situation. You got two photons, the things that make up light. You've seen photons. Actually, photons are all you've ever seen. Okay, so photons, however, so two photons leave a source traveling in opposite directions. Now, spin is this property of particles, and it's not actually spinningness, but the spin is, imagining it as they're actually spinning is fine here. So spin is conserved. That means you end up, in any particle interaction, you end up with the same quantity of spin that you started with. Okay? So two photons leave a source. One of those photons is going to end up with a spin of 1, and one of them is going to end up with a spin of -1, because photons always get whole numbered spins. So it's going to be, one of them's got spin 1, one of them's got -1 spin. So far, so good. That's all normal. None of this is weird yet. Okay. One of the weird things that bothered Einstein about quantum mechanics was that, in fact, until those photons interact with something, until they land somewhere or observed somewhere, they don't actually have one spin or the other. And I want to emphasize, it's not just that we don't know what spin they end up with, it's undetermined. Until it's observed, the actual spin of the photon is not determined. As a matter of fact, it's not spin 1 or spin -1, it's spin who knows. So that is somewhat weird and it's somewhat disturbing, but not the most disturbing part of this story. So is that reasonably clear that we've got two photons zooming off in opposite directions, and they're going to end up with spin 1 and spin -1, but it's not decided yet until they land somewhere. It's not decided which one will be plus and which one will be minus. Okay. So this is where it gets really weird with quantum entanglement. So because these two photons we're considering started in the same place, they are entangled. These are entangled particles. So what happens is when one of them is observed, when one of it lands somewhere, it acquires a definite spin. It ends up as either spin up or spin +1 or spin -1. Okay? Which means that once one of them is observed, because spin is conserved, the other one acquires a definite spin. And that can happen across great distances. So in 2017, a group of scientists did this across 1,200 kilometers. They bounced particles to a satellite and back before they were observed. They had to send about 6 million particles for every one that made it through the atmosphere, but nonetheless, they were able to keep entangled particles unobserved to go from a city up to a satellite down to another city. So what we know now, so you can have these entangled particles get really far apart before one of them is observed, but as soon as one of them is observed, instantaneously, the other acquires a definite spin. And that's what Einstein called the spooky action at a distance. Okay. It seems like these particles are communicating with each other across potentially very great distances. We managed to do, well, the scientists managed to do it at 1,200 kilometers. Theoretically, you could have them light years away, and they would still, as soon as you observe one of them, the other one would acquire definite spin. But they don't use up any energy to do this. And this image, so if you Google quantum entanglement, what it shows is like a lot of pictures of particles with like glowing energy lines between them. That's exactly the wrong way of thinking about this, because there's nothing, as far as we can tell, there's nothing connecting these particles. And furthermore, they can be so far apart that they're communicating faster than the speed of light, which we have really good evidence that nothing goes faster than the speed of light. Okay, so really odd that if something happens to one of them, right, the other one seemingly responds instantaneously with no energy and like across as large distance as you want. So that's spooky action at a distance. Okay? Okay. So now, as I said, it's not the first time we've had action at a distance in physics. Like Newtonian gravity is also action at a distance. And, you know, people, when Newton came up with this, people didn't like it. They didn't like the fact that gravity seems to act across distances with no apparent mechanism. Newton himself thought, well, maybe God does it. Right? He actually came to think that this maybe is an argument for the existence of God, because as we know, the world is just made up of mechanical causes. So if you see something happening regularly with no mechanical cause, maybe it's God. Right? So they didn't love it, but they kind of got used to it. I mean, here's what people like. Here's the kind of explanation people like the best. It's mechanistic explanations. We love mechanistic explanations. These are explanations that just involve pushing and pulling, because we know what pushing and I've felt a push, I have felt a pull, right? I know what those base level entities are. So if you can take a phenomenon and break it down into just pushing and pulling, oh, we love that. It's our favorite thing in the world. We prefer for the pushing and pulling to be direct, right? So you can see how the pushing and pulling happens. But with the case of Newtonian gravity, people just kind of got used to it. You know, it hangs around for a couple centuries, and people are like, yeah, it's not that spooky anymore, right? We stopped finding it to be weird and unsettling. We just accepted that this is like, yeah, gravity happens across distances. We didn't love it, right? It's still a kind of, I wish we had an explanation for it, but it didn't give people the heebie-jeebies, right? It didn't creep people out that this was happening. So, why would Einstein, who was very familiar with Newtonian mechanics. This was not like a surprise to him that Newtonian mechanics involves action at a distance. He was very familiar with this. Why would he be disturbed by action at a distance in quantum mechanics? What was it about that was disturbing to him? And to answer that, I want to go via this question of what makes something spooky in general. So I'm going to do a detour right now, and we're going to talk. So that was what is quantum entanglement bit. Now we're going to do what is spookiness, and then I'll come back around to tell you how that applies to quantum mechanics. Okay. So I want to use this idea that comes out of Mary Douglas's book. This is we're going to do some anthropology now. So Mary Douglas writes this very famous book, 1966, Purity and Danger, an analysis of the concept of pollution and taboo. So I want to use the ideas from Mary Douglas's book to do an analysis of spookiness, which I'm then going to apply to the quantum mechanics case, if that's okay. Okay. So every culture has a purity code. A code about what counts as clean and what counts as unclean. Okay? If you look across cultures, there's always one of these operating. And basically, I propose to analyze spookiness in terms of purity codes. So, it's tempting to think that, oh, I know what a purity code is. If it makes you sick, then that's unclean, right? You don't shovel actual dirt into your mouth because that will make you sick, and therefore it's unclean. But I want to insist that that is not how purity codes work. Okay, so there are lots of things that you will find, and we have a purity code in our culture as well. There are lots of things that you will find unclean that won't make you sick. So, for example, okay, I'm going to take a sip of my coffee. Everybody okay with that? I'm going to swallow the saliva in my mouth. Everybody good? Okay, now, I'm not going to do this, but what if I spit a... Alex wants me to do it. Okay. Yeah. Thank you. That was the reaction I was hoping for. That's gross, right? That's disgusting. I found that disgusting, and it's my spit. So why is it that it was okay for me to swallow the spit in my mouth, and it's okay for me to swallow the coffee, but swallowing the spit that was in my mouth like half a second ago, once it goes in the coffee, is disgusting now. Ugh. Or like, yeah, so lots and lots of examples of that kind of thing, where it's clearly not that it's going to make me sick, right? It's not that my own saliva is going to make me sick. It's that, let me tell you. So, okay, so, actually, hang on. Was there one more thing I want to say about this? I think there was one more. Let me check my notes. So, sorry, I'm a little flustered by having swallowed my own spit. That was a little disturbing. Okay, so let's also distinguish moral codes from purity codes. Okay, so a moral code is against something that you think is morally wrong, you think is bad. You would feel guilt if you violate a moral code. So, for example, I'm mostly a vegetarian for moral reasons. It is not that I find meat disgusting or unclean. Actually, it looks delicious and yummy to me, okay? So it's not that I see a juicy burger and I'm like, ew, gross. I'm like, but no, the cows, right? So that's a moral rule that I have for myself. It's not a purity code. Now, but imagine, instead of a factory farm chicken, you had a chicken that a family had taken into their home. They'd given it a name. They called it Steve. And they gave it scraps from their table, and the kids played with it. And then one day they killed it and served it to you. You'd be like, no, Steve. I'm not eating that. I'm not eating Steve. God. Okay, but morally speaking, that's way better than factory farm chicken, right? That chicken had a great life. It was cared for. It had a nice, beautiful life. But so it's morally speaking better, but it's still very like, ugh, I wouldn't eat Steve, right? Would you eat Steve? Yeah, Alex would eat Steve. All right, all right. Well, that's not a purity code for you then. Okay, okay. So here's the explanation. Here's what I think, here's what Mary Douglas thinks, and here's what I think explains these purity codes, the structure of these purity codes. Is that what we want, what we hate, is when something messes up our important explanatory categories. Okay? So whatever your life is like, you've got important explanatory categories that you operate by. For example, here's a really important explanatory category. Things that are part of my body and things that are not part of my body. You're going to split the world up into things that are like body parts and non-body parts. And that is a crucial explanatory category for you, right? You're allowed to do things to non-body parts you are not allowed to do to body parts, right? Right? If somebody puts their coat on the floor, I'm allowed to pick it up and hand it to them. Whereas you don't want like skin-to-skin contact with it, like except under exceptional circumstances, right? So really important explanatory category, body parts, non-body parts. And then when you spit, something goes from being part of your body to not part of your body. So I don't like seeing spit on the sidewalk either. I'm like, that's a body part, right? And then if it goes back into your body again, that's doubly disgusting, right? That's like, no. Sorry, just have a sip of my coffee. Okay. Same thing with the chicken named Steve, right? Here's a really important explanatory category: family and food, right? These are categories that we want to keep separate, right? There are animals that are family: your dog, your cat, maybe you have a horse, right? Those get names. They get treated to like, you take them to the vet if they get sick, kind of thing. And then there's animals that we treat as food. Yeah? So this is a crucial explanatory distinction that we make. You understand the status of these beings in terms of what category they fall under. And if something messes up those categories, you don't like it. I don't like it. None of us like it when something messes up your basic explanatory categories. Hate it when that happens. So Mary Douglas applies this to a bunch of stuff. The most famous one is the abominations of Leviticus. So here's a little bit from the Torah and from the Old Testament. Leviticus lists a whole bunch of things that you are allowed and not allowed to eat, or a clean and unclean animal. So if you touch a clean animal, you're allowed to go to temple right afterwards. That's fine. If you touch an unclean animal, you have to go through a ritual cleansing before you're allowed to re-enter sacred spaces and stuff like that. And people spend a lot of time trying to puzzle out, why these animals? Why these animals? So every animal that parts the hoof and has the hoof cloven in two and chews the cud, among the animals you may eat. Yet of those that chew the cud or have the hoof cloven, you shall not eat these: the camel, the hare, the rock badger, because they chew the cud but do not part the hoof, are unclean for you. And the swine, because it parts the hoof but does not chew the cud, is unclean for you. Their flesh you shall not eat, and their carcasses you shall not touch. So what? Why? What's going on here? That some of these are clean and some of them are unclean. Douglas goes through a bunch of potential explanations. The one that she kind of ends up with is the following. In the general underlying principle of cleanness in animals is that they shall conform fully to their class. Those specimens are unclean which are imperfect members of their class, or whose class itself confounds the general scheme of the world. So for the culture that was writing Leviticus, animals that chew the cud, they chew the cud means like they regurgitate, they eat a bunch of grass and then they regurgitate it back into their mouth and chew it some more and then swallow it. That's chewing the cud. And there was a bunch of animals that they would farm that had that property and also had cloven hooves. So they found, in their explanatory categories, those things go nicely together. They fit well together in their heads, right? This is a nice exemplar of the category of four-legged cloven hoof cud chewers, yeah? But if something messed up those categories, they didn't like it. They found it to be unclean. So here's my proposition to you. Here's an empirical prediction. If the people who had written Leviticus encountered a penguin, they would not be willing to eat it, right? Because it's a bird, it's got a beak, it's got wings, it's got bird-like feet, but it doesn't fly. It's not a good exemplar of its class. It messes up our categories, right? It provides it's an object that falls in between our categories. And therefore, we're like, ugh. I should say, Douglas distinguishes between things that we find gross when they mess up our categories and things that are actually regarded as sacred because they mess up our categories. So holy people from lots of cultures would do things like cross-dress, right? So if you're a holy person, you're allowed to mess up the category. You're sort of outside of the normal order of things. But for ordinary stuff, like stuff you're going to put in your dinner, it needs to fall neatly within our categories. Okay. Modern version of this is the uncanny valley. That's just horrifying to look at, isn't it? It's just utterly horrifying. So here's an important explanatory category for you: people and not people. What is that? It's not really a person. It's not really not a person. Horrifying. Just horrifying. Huh? Okay. And to bring it to the Halloween themed, I think you can understand the normal Halloweenish things in precisely these terms. So, vampire, is it alive or is it dead? It's kind of in between, isn't it? The mummy, it's a dead thing that moves around. Right? It's creepy because it's participating in both the living and dead categories. Zombies, exactly the same thing. It's a dead body that moves around. It's messing up my categories and I don't like it. Huh? I don't know what this is. It has a pumpkin for a head. I don't know, that's not even a thing. But same thing with Frankenstein's monster and the Wolfman. The Wolfman, is it an animal? Is it a man? Okay, so all of these are things that mess up our basic explanatory categories and give us this uncanny, unsettled, spooky feeling because they do precisely that. Okay? Okay. Now, to premise 2. I want to propose that action at a distance is not in general a spooky phenomenon. So I don't know if any of you have seen Avatar: The Last Airbender. If you have not, I think you should stand up right now and walk into this room and go watch it because it's fantastic. What's that? No, okay. It's on Netflix. Okay, maybe after my colleagues speak. Okay, so in Avatar: The Last Airbender, there are characters who can manipulate the elements with their minds, I suppose. And one of the really appealing parts of the show is how fluidly, so this is Katara and she's moving water. She's going whoosh, and she's shooting water. And there's nothing unintuitive or spooky about it. You're like, yeah, if I could move water with my mind, that's exactly what it would look like. That's exactly what it would look like. Very fluid movements of and you can see there's no contact here. But you see it and you're like, yeah, of course. And you can show a kid this and be like, yeah, that's what it would look like. If I could shoot fire out of my hands, that's exactly what it would look like. But there's nothing unnatural or unintuitive about it. And nonetheless, it's action at a distance. So I want to propose that in general, action at a distance is not spooky. However, perhaps quantum entanglement is spooky for the following reason. The explanatory category that I propose as being messed up in quantum entanglement is the category of object, one of the most basic categories you can think of. What's an object? Well, an object is a bundle of features, right? It's a bundle of features tied together by a location. Yeah? What makes an object is that it's got a bunch of different features that are all collected together. And if you move the object from one place to another, all the features go from one place to another. It's not like if I take my coffee and it's warm and weighs 200 grams, it's not like I move it over here and the 200 grams stays here and the warmness moves, right? The properties are supposed to stay collected. That's what an object is. That's what an object does. It's a nice little package of properties. But what's happening in quantum mechanics, what's happening in entanglement is the properties aren't staying together. The properties like conservation of spin, the spin's got to be conserved, so one of them's got to be spin up, one of them's got to be spin down, right? But those properties don't stay together in a spatial location, right? if you're in the formalism of quantum mechanics, you can only represent a pair of entangled particles as one wave function, right? So you can't even write down the formal description of one of these entangled particles without the other. So in the formalism, they are one object. But object is supposed to be a thing at a place, right? That's all of the objects I know have a location, not just all over the place. So my proposal is spooky action at a distance is spooky because it messes up the fundamental explanatory category, object. All right? So to review, ancient Judaism would have found penguins to be an unacceptable meal. Avatar: The Last Airbender is fun to watch. Therefore, quantum entanglement is the spookiest. Thank you very much.